What if your body could speak directly to artificial intelligence? And what if the AI could understand not just your words, but the subtle language of your movements? In today's digital age, we are increasingly detached from our physical selves, constantly immersed in screens and devices. Yet, our bodies remain the core of how we experience life, build relationships, and interpret the world around us. Through gesture, posture, and movement, we express ourselves in ways that words often can't capture. Hi, I'm Natan Sinigaglia, a sound visual digital artist with a background in contemporary dance and music. My project, Simbody, explores how AI can detect subtle features of body movement, potentially revolutionizing human-machine interaction. Simbody aims to reconnect us with the power of our physical presence in an increasingly virtual world. The goal of the project is to train AI systems to perceive nuanced aspects of movement, unlocking new possibilities for interaction that feels more natural and intuitive. By focusing on dance as our case study, we explore how AI can help us perceive new layers of meaning in the relationship between body movement and sound. From the start, InfoArt recognized the potential of Simbody to push the boundaries of human-machine interaction. Their support was tailored in connecting us with AI experts, mentoring the research, and providing the resources needed to turn our concept into reality. Through their network, we were able to consult with AI experts, including Dejan Mircetic. These experts validated our approach, emphasizing that using a multimodal framework to track meaningful patterns in human behavior is a holy grail in the field. However, they also clarified that our few months would only allow us to scratch the surface of this complex subject. This collaborative foundation set the stage for our deep dive into the mechanical and artistic challenges of teaching AI to understand the nuances of human movement. In collaboration with TMC, we began by analyzing existing projects exploring the relationship between body movement and machine learning. This research phase was crucial in identifying potential opportunities and challenges for Simbody. We were inspired by Michael Lynn's experiment using machine learning to encode music into 3D space representation. This approach of simplifying complex phenomena into visual forms resonated with Simbody's aim to represent intricate body motion patterns in an accessible way. For our dataset, we utilized the IST++ collection, which offers over 1,400 dance samples with 3D motion capture data and associated music. This comprehensive dataset allowed us to focus on refining our models rather than starting from scratch with data collection. We developed a training pipeline for sequential skeletal data using an autoencoder architecture. Given the experimental nature of our project, we created a bulk training pipeline capable of training thousands of models, systematically exploring various configuration settings. To efficiently explore and compare the thousands of generated models, I developed a real-time visualization tool. This software represents how dataset samples are encoded within each model's latent space, allowing us to navigate through spatial features, examine training configurations, and sort models based on various criteria. Collaborating with Pina and Heka in Cooper, we expanded our exploration into sound. We asked, why not to give these models a voice to express their interpretation of body movement? By sonifying the 3D trajectories produced by the models, we add another layer of sensory engagement. This auditory feedback allows us to further connect with the machine's perception of us, offering a new way to recognize and relate to the patterns it detects in our movements. In the final months, we made significant improvements to the machine learning software. Kandevel Pasupati-Pillai from TMC added real-time inference capabilities, enabling us to test trained models with live skeletal data from a Kinect sensor. We also experimented with attention layers, a technique drawn from the revolutionary Transformers architecture. By the end of the residency, we achieved several key milestones. a customizable machine learning pipeline, a model database visualization tool, and a prototype for a real-time interactive installation where users can experience how the machine interprets their movements through 3D visuals and synthesized sound. Looking ahead, I see exciting possibilities for the project's future development and its applications. I am particularly interested in using Simbody in the context of live performances, such as dance, theater, and other hybrid practices. Simbody offers more than just an engagement with AI. It invites us to rediscover our own embodied intelligence. This journey is as much about understanding how AI perceives us as it is about deepening our own awareness of how we express ourselves through movement. It suggests a future where human-machine interaction becomes more seamless and symbiotic, enhancing not only technology, but our relationship with ourselves and the world around us.